Because the math develops
But what if you
as you
don't,
go along.
like, understand anyways and you just jump to the end?
Then you just wouldn't understand the end or the algebra needed to do it. Okay, so our new method for graphing this other than table of values is we are going to, which we already did know, we know the end behavior. This is, oh, I should spell it the Canadian way. We know the end behavior. This acts like a line. It's an x cubed graph, an odd function. The end behavior is going to act like a line. And then 2, find all x and y intercepts. How do we find our x and y intercepts?
You'll feel better now that you hear the dumb questions that we ask everybody.
Yeah.
Why is it a pi over 12 question?
So the y-intercept is the easiest to find. Okay? You plug in 0 for x, and it's going to be 0. The x-intercepts, you plug in 0 for y. How do you solve something when you plug in 0 for y? You'll have to factor. And sometimes you'll have to factor a cubic. Sometimes you'll have to factor a quartic. This one is the easiest one to factor because this would be a grade 10 factoring question. It is. You see the x cubed and you think grade 11 already or grade 12, but it's a common factor. You could just pull it out. And then what's left is another easy factoring one. And it will be x and x plus 3 and minus 2. So your x-intercepts are x equals 0, x equals negative 3, and x equals 2. So if you know the end behavior and you know all your intercepts, in grade 12 they will accept this as enough for a graph. You label all of your x and y intercepts. So we have 1 at 0, 1 at 2, 1 at negative 3. And the end behavior acts like a line with a positive slope, right? So you know that it starts down here, goes through that point, curved through that point, and up. And here you have your sketch, accurate enough. Again, we don't need to say exactly where the maximum or minimum are. If you wanted to be more accurate, you could do a table of values and plug in some values. But this will be accepted. Yes?
So how do you know that it doesn't just like plateau along the x-axis and go up?
Like, how do I know that it doesn't just flatten out here?
Yeah, like, because like that's possible for an x cubed graph. Because
No, x cubed graph will always go up forever just like a line.
no, like doesn't like.
Oh, like go like
Do you know what
like
I mean?
this?
Yeah, and then
Flat?
up from there.
Because it has to be, it will curve like that. It'll be a smooth curve through all of them.
Which is always will be.
Yeah.
It'll never flatten.
It'll never flatten out. In order to be completely flat, you have to imagine that there could be an infinite amount of x-intercepts. Right? If I have a completely flat, that means all of those are possible x-intercepts, which means I could factor forever and have a whole billion of them. And then you'd have more than an x cubed. And because it's positive, it needs to have the end behavior like this. That's why it starts down here and has to end up there. Okay, so part A. Part A was the easy one because of the way it factored. Oh, there was no part B for that one, was there? All right. We will do question 3 so we get into some more fascinating ones. I have volleyball intramurals. 7 and 13 for this one.